Oh, hi guys. We're going to start today's lesson with a little game. And inside this brown paper bag, there's an object in here. And your first CFU is going to be to guess what that object is. So the object is brownish red colored. It smells a little metallic. It's not magnetic though. It's circular. Can you guess what it is yet? If you guess penny, you're right. And I didn't have to change anything about the penny when I tested it. In fact, I could test the density. If I put it in water, it sinks. I could test the magnetism. Not attracted to magnets. In addition to using my five senses, smell, see, feel it. Anytime you can describe a property without changing the actual matter, that's a physical property. Physical means without changing the matter. So let's write that down. So the first thing we know is that we can observe physical properties with our five senses. So this is sight, smell, touch, feel. We could also measure. So I also could have said it's 2 centimeters wide. Because I can measure that penny without changing it. And we know if we don't change it, it's a physical property. In science, we have some special words for our five senses. When we feel, that's called texture. We also have smell and color. Now, there's some more scientific ones that we're going to do, and the first one is solubility. That means if something mixes with water. What do you mean if it mixes with water? Let's take a look. Here's my water, and the first thing I'm going to try to mix is chocolate syrup. As you can see, or maybe you can't, there we go, the syrup goes straight to the bottom and it doesn't mix with the water. But once we stir it together, we see it's soluble. It mixes together or combines. The same is true with salt. Especially if your water's hot, when we put salt with something, it's soluble. It mixes. Things that would not be soluble would be if we tried to add oil. That would be non-soluble. It's still physical because even though it looks like the chocolate syrup and water have changed, if we actually had this evaporate, we would find chocolate syrup at the bottom. Same thing with our salt. If we had this evaporate, the salt would be left at the bottom. So it didn't actually change the molecules. The molecules are still the same, which is why solubility is a physical property. The next physical property is magnetism. You probably know this one already. Magnetism is if it's attracted to a magnet. And it only is going to be attracted to a magnet if it contains iron. For example, we've got a foil ball. I thought tin was metal. But remember, magnetism only works if something has iron in it, and this is tin, even though they're metals. This one is magnetized. The binder clip must have some iron in it because it's magnetic. Our next vocab word is conductivity. This one means it passes electricity through it. Conductivity allows electrons to get through. This is going to be all metals, not just iron. For example, let's take those other types of matter that we tried and see if they're conducting. This might be hard to see. We're going to start with the foil ball. This is our circuit. We have our power source and our light bulb, and we're going to just connect our tin foil to it. As you see, the light bulb lights up. Can you see that? No, I can't use the way. There we go. It lights up, so I know there has to be metal in it. Dear Lord, we gotta fix this. Let's move this here. Sorry. Not a camera person, just a science teacher. There we go. So it's lighting up. Now let's try the same with the binder clip. Well, I see that the binder clip is metal, so I'm gonna assume it is. You can't see as much, but it's certainly lighting up. Next, let's test an apple. Do we think the apple is going to be conductive? Nope. Apple has no conductivity, but we know that our metals, like our tin foil and our binder clip, do. The important thing to note, all metals are conductive, but not all metals are magnetic, because we know magnet needs iron. Did I change the foil at all? I did all these tests. Did I change the binder clip at all? So magnetism, conductivity, solubility, again, physical properties. We got one more to go over. Viscosity, this one's a fun one to test. Viscosity just means if liquids flow. If liquids flow, if they're sticky. And an example of that would be syrup, because I'm struggling here today, sorry. Syrup has a high viscosity. So what would be something with a low viscosity? Well, a low viscosity would flow easily. Something that's really not dense or not thick, like water. Right? It flows right out of the bottle. That would be low viscosity. Something that's really thick, like our syrup, takes a little bit longer. That's gross. This bucket is gross. To flow, so it is highly viscous. I didn't have to change the syrup. I didn't have to change the foil. I didn't have to change any of these objects to see if they were soluble, if they were magnetic, if they were viscous, or if they were conducting or conductors, conductivity. So that was all physical properties. Today you're going to observe a few more on your own and then practice independently. Good luck.